I've always been somewhat skeptical of marketing claims, so today I'm putting one to the test. This is a Choco Monaka Jumbo. Made by snack maker Morinaga, it's Japan's top-selling ice cream. So what is a monaka? It's a traditional Japanese sweet, a wafer made from mochi rice flour. It's baked until crispy, then usually filled with sweet red bean paste. Modern versions swap the beans for ice cream, creating a portable, handheld sundae. However, a problem arose. Monaka wafers are crispy because they're dry, but they're also great at absorbing moisture, which doesn't exactly make them the best match for ice cream. Morinaga addressed this issue by spraying a thin layer of chocolate inside the wafer, which acts as a hydrophobic barrier, slowing melted ice cream from soaking into the wafer and turning it soggy. This sounds reasonable, but does it actually work? Or is this just big snack marketing? In this video, I will test the claim that the chocolate layer in Choco Monaka Jumbo keeps the wafer crispy by slowing the absorption of moisture. I wanted to let two specimens, one untouched, one with the chocolate layer removed, sit out and record their weights. If the claim is true, the wafer with the chocolate layer should absorb water more slowly, and thus gain weight more slowly. But ice cream is messy. It sticks to the wafer as it melts, making it impossible to tell the difference between absorbed water and stuck dairy. I thought about wiping it off, but I was scared of also wiping chocolate off, which would ruin the experiment. Just like the wafer, I was stuck in a sticky situation. In the end, I decided to go with a modified approach, a surrogate moisture source. I replaced the ice cream with a wet sponge. The downside? It was no longer in situ, Latin for in its original place. But the upside is that I now had a method that could deliver consistent results. Here are the steps. 1. Take the Monaka wafer from the ice cream, which comes apart into 2 shells. 2. Wipe the chocolate off of 1 shell. 3. Place an identical wet sponge onto each shell. 4. Every few minutes, take the sponges off and weigh each shell. Let's get to it. The plain wafer absorbed more water at every measurement, letting in over 40% more between 6 and 12 minutes and a third more water at 30 minutes when I ended the experiment. That supports Morinaga's claim. The chocolate layer does slow moisture getting into the wafer. But I'm not fully satisfied, because this setup is almost too clean. 1. It's a highly idealized setup, degrees removed from the real thing. A sponge with water is not a brick of frozen ice cream. And 2, the real crux of the matter is crispiness. Weights on a scale don't tell the full story of the crunch. So even though these numbers point in the right direction, they don't feel like the final answer. What I really want to know is whether the chocolate layer still matters in situ with respect to the crispiness of the wafer. That's right, a second experiment has just hit the Monaka. A crispy wafer snaps. A soggy one bends. For practical reasons, I don't want to be snapping a bunch of wafers. I already ate so many Choco Monaka Jumbos testing and doing my first experiment, my doctor says my risk of heart disease just doubled. So instead of forcing a snap, I'm watching how it gets bendy. To do that, I'm using a 3-point bending test. I will create a Monaka bridge with the ice cream still inside and put a weight on top. As the ice cream melts, moisture will move into the wafer and it will soften and sag. If the chocolate layer works, given the same weight, it should slow that sag. Will the wafer be stiff enough for the job? Or will it suffer from structural dysfunction? Here's the experiment. Supports 2 Choco Monaka Jumbos, 1 intact, 1 with the chocolate layer wiped off. 500-gram weights to induce sagging. And I'll be measuring how much the center of each block sags.
Ready, go!
A quick note, the block on top of the chocolate-coated wafer tilted backwards over the course of the experiment, while the other did not, so I needed to account for this in my measurement calculations. Both wafers sagged as the ice cream melted, but the plain wafer sagged faster. That suggests the chocolate layer really does slow down how quickly the shell loses stiffness as moisture gets in. But after about 75 minutes, something unexpected happened. The chocolate-lined wafer fractured. Once that crack formed, it started sagging heavily and the weight tilted and slid off. At that point, the comparison stopped being fair, so I ended the experiment there. What's interesting is that the chocolate-lined wafer actually cracked. It stayed stiffer for longer, but it also had some visible damage from the start, right where it cracked. In a stiff, crispy material, damage like this acts as a giant stress concentrator. Because the wafer refused to deform and redistribute the weight, the stress piled up around that specific weak point until the wafer reached its limit and snapped. This collapse is similar to what happened to the Sleipnir A oil platform in 1991. During construction, it developed a major crack, then catastrophically imploded and sank because pre-construction analysis had underpredicted stress concentrations. Although in my case, my lack of foresight merely led to the failure of a wafer, not a 700 million USD disaster. On the other hand, even though the plain wafer also had some damage from the beginning, it became so soft and ductile that it simply deformed, and never concentrated enough stress for the damage to get worse. Let's revisit Morinaga's claim of moisture out, crispiness in. In the moisture test, the chocolate-lined wafer absorbed water more slowly than a plain wafer. That's direct evidence that the chocolate acts as a moisture barrier. And in the in-situ bending test, the plain wafer softened and sagged faster, while the chocolate-lined one stayed stiff for longer, and when it failed, it cracked. That means it still had some crispness till the very end. Therefore, Choco Monaka Jumbo's chocolate layer is more than just a marketing gimmick. It's real engineering that works. Claim confirmed. If you've made it this far, thank you very much for watching. And if you enjoyed this deep dive, please like and subscribe. What Japanese snack should I deep dive next?